Okay, so the first question here will be find the equation of the circle. Now, by looking at the circle visually, we can see that the centre point of this circle is 0, 0. And as a result of that, we know we're going to use this formula. X squared plus y squared is equal to r squared. Now, if we look at the length of the radius, we can see visually that the radius is 5. So for this question, we can see that the radius is 5. So we're saying x squared plus y squared equals to 5 squared. Tidy that up. So we get x squared plus y squared is equal to 25. Now for part 2 of the question, what we're going to have a look at is we're going to have a look at find the equation of the line. Now this line is a chord because it intersects the circle in 2 points. So we're going to do this using our y equals mx plus c, where m is the slope and c is the y-intercept. So let's look at the y-intercept first of all, and we can see clearly that the y-intercept here happens at 5. So as a result of that, we can come along and we can say that the c in this case is plus 5. Looking at our slope then, because it's a negative line, we realise that our slope will be negative. So using our rise over run won't work here. We'll have to use fall over run because we're looking at a negative slope. So looking at the fall over the run here, we can see that we fall 1, 2, 3, 4, 5. So we have a fall of 5 and we have a run of 1, 2, 3, 4, 5. We also have a run of 5. So by simplifying that, we can see that our equation of a line is minus 1x plus 5. Now for part 3 of the question now, we're going to find the points of intersection. And in maths, when you're asked to find the points of intersection, that should give you a good indication to use simultaneous equations. Now we can see what they are from the graph, and from the graph they look to be 0, 5 and 5, 0, but we're hoping that using algebra we'll be able to prove that. So the equations we're working with are the equation of the circle first of all, and then secondly we're working with the equation of the line. So let's have a look at how we're going to solve these now using our algebra. So what we're going to do is we're going to replace this y with the value given for y in the linear. So what we will have was x squared plus minus 1x plus 5 all to be squared is equal to 25. This will give me x squared minus 1x into minus 1x plus 5 into minus 1x plus 5 is equal to 25. Simplifying that down will give me the following. Which will give me 2x squared minus 10x plus 25 minus 25 is equal to 0. To give me 2x squared minus 10x is equal to 0. And dividing both sides by 2 now, we can see that x squared minus 5x is equal to 0. So using our factorization, we can take out the common factor to give me x is equal to 0, or x minus 5 is equal to 0, so x is equal to 5. So at this stage now, we have two values for our x's. We have x is equal to 0 and x is equal to 5. And if we look back up and check that on our graph, we can see that indeed x was equal to 0 and x was equal to 5. So we're looking good. What we have to do now is we have to confirm that our two y values turn out to be 5 and 0. So by returning back down here, we know from earlier that y is equal to minus 1x plus 5. And we have said that x is equal to 0 firstly. So this will mean that y is equal to minus 1 times 0 plus 5, which will give me 5, which is exactly what we were hoping for. So I get a first point of intersection of 0, 5. The second value we found for x above here is x is equal to 5. So substitution that value in, we have y is equal to minus 1 times 5 plus 5, which is minus 5 plus 5, which works out to be 0, which is exactly again what we were hoping for, to give us the second point of intersection of 5, 0.